Hello students, I hope you enjoyed the last session. I am still Mr. Femi Lawal. I'm your math teacher, and I want to continue with we defined inequalities as a relationship between two numbers, quantities, or expressions that are not equal. And we're made to understand that there are symbols that we use in representing inequalities. We have less than, like I mentioned the other time. This left elbow represents less than, and greater than the right elbow. And we solved some questions, and we explained the principles that we use in solving equations. Equations are the same as that of inequalities, except in a situation where you have to divide both sides by a negative coefficient. Last class as well, we represented some inequalities on number lines. So in this new session, we want to achieve these two objectives: how to solve word problems and how to plot graphs of inequalities in 1 and 2 variables. Now, let me briefly explain how word problems are solved. Most of us, once we see words and we're asked to interpret them mathematically, we get confused. All right, but I want to explain how we do that. The first thing to do is to read through the statement, read from the beginning to the end of that question. Then, once you do that, you'll be able to identify the problem, which is a question. Once the question is identified, then the next thing is to go back again and read the sentences in that question and interpret them mathematically. Once that is done as well, you need to identify what method is suitable for such mathematical statements you have done. Then finally, you apply that method you feel is suitable. And then once that is done, don't go away. Make sure you look back. To look back means to check whether your solution is correct. And we're going to take some examples now, quickly. I believe by the time we finish this, you will not have issues with word problem again. Question number 1. This is what we asked us to do. Example number 1. If 4 is added to a certain number, the result is less than 15. If 4 is added to a certain number, the result is less than 15. Find the range of values of the number. Now, with this, I have gone through that question, and at the end of that statement, and at the end of the statement, the last sentence there is giving me the problem. It states that I should find the range of values of the number. So I know what the problem is. Now I am going back to interpret this mathematically. Now, since the statement says I should find the range of values of the number, and from the beginning, the statement says if 4 is added to a certain number. What is the certain number? We have to represent that with a variable. Tell me, let the certain number be x. Let the certain number be x. Now, if the certain number is x, and the statement is saying if 4 is added to that certain number, so you have x plus 4. X plus 4. There, I'm reading the statement, the sentences now. I want to put them together. If 4 is added to a certain number, the certain number is x, I'm adding 4 to it. The result is, now, when this statement says is, we are talking about, we are saying, it means that we have a left-hand side and a right-hand side. But before we do that, before we use this, originally, you would have used the equal to, but for the fact that you have less than, this is not applicable again. Equal to is not applicable. So you say it's less than 15. The sign for less than is the left elbow, and you have less than 15. Hello? Now, I have done 1 and 2. The next one is to identify a suitable method. What method are we applying here? We know this is an inequality, and we have said earlier that the principles we use to solve equations, they are the same thing with that we use in solving an inequality. So all I need to do is to either add and subtract 4 from both sides. Subtract 4 from both sides. Why am I doing this? I'm doing this because the question wants me to find the value of x. And to get that, you have to make x subject of the formula. So doing this, I have x plus 4 minus 4 less than 15 minus 4. Then you have 4 minus 4 is 0, so you have x less than 11. 15 minus 4 is 11. Check. If x is equal to 11, then you have x plus 4 less than 15 will give you 11 plus 4 less than 15. Is this right? Is this correct? No. Because you have 15 here, and 15 is equal to 15, but the statement is saying the left-hand side is less than 15. That shows that the range of values will now be less than 11. Numbers that are less than 11. And what are the numbers now? You have 10, 9, 8, and so on. So this is the range of values the question wants you to bring out. So that has been solved. Definitely, if you put 10 here, 10 plus 4 definitely will be less than 15, and that is what the statement has given us. One is okay here. Now, let's come back to this point. Assuming I don't want to use this method, I can do this. You know, the direct method of moving, collecting the like terms. Move the 4 to the right hand side so that you have x less than 15 minus 4, and your x is less than 11. So you still have the same result. Question number 2. If 7 is subtracted from 2 times a certain number, the result is equal or greater than 8. Find the range of values of the number. I have gone through the question and I have identified the problem. The question says I should find the range of values of the number. Now, let me go back to the beginning, the first sentence there. If 7 is subtracted from 3 times a certain number, what is the number? Now, let me say, let the number be m. Yes, let me use a different unknown variable now. Now, let the number be m. 3 times the certain number. 7 is subtracted from 3 times a certain number. The certain number, 3 times a certain number will be 3m. And subtracting 7 from me to mean minus 7. The result is equal or greater than 8. greater than or equal to 8. So I have the mathematical form of this statement. How can we solve this? You either add 7 to both sides or you move 7 to the other side. So if I'm adding 7, add 7 to both sides. Then I'll be having 3m minus 7 plus 7 greater than or equal to 8 plus 7. The concept of adding 7 here is to remove the negative 7 from the left hand side to the right hand side. And removing this negative 7, you need the additive inverse of 7, which is of minus 7, which is plus 7, to add to both sides. Remember, whatever you are doing to the left hand side should also be done to the right hand side. Therefore, I have my 3m, because negative 7 is removing positive 7, greater than or equal to 15. So at this point, you need 3m. You need m to be the subject of the formula. So you have to remove 3. How do we remove 3? Use what is called multiplicative inverse of 3. What is the multiplicative inverse of 3? 1 over 3. Therefore, I can multiply both sides by 1 over 3. Therefore, you have m is greater than or equal to 5. Otherwise, you have 3m minus 7 greater than or equal to 8. Move this away. 3m greater than or equal to 8 plus 7. And 3m is giving me 15. Divide through by 3, which is the same thing as what you did earlier. So you have m is greater than or equal to 5. Now, the range of values here will just be greater than or equal to 5, meaning that you have from 5 and above, 6, 7, 8, and so on. So that's the solution. Question number 3. Now, this is saying the sides of a rectangle are x and x plus 3. What is the range of values of x if the perimeter is equal or greater than 24 cm? Now, I have identified the problem here. The question wants me to find the range of values of x. Now, in this situation, I will put up a rectangle just to help my solution. Now, if this is a rectangle, of course, you know you have the length longer than the width, the breadth. So if the statement says the size of a rectangle are x and x plus 2, that shows that the length is x plus 2 and the breadth is x. So that's one. It says I've been given the perimeter. And what is the perimeter of a rectangle? The perimeter of a rectangle is 2 into length plus breadth. Yes, the perimeter of the rectangle means you should add the 4 sides together. So, and I have been given that the perimeter is 24 cm. Okay, the statement says the perimeter is greater or equal to 24. Therefore, I have 2 into this x plus 2, that's for the length, plus, let me put it this way, plus the breadth, x, greater than or equal to 24. This is the perimeter. So from here, all we need to do is to expand this bracket, or we divide through by 2 to reduce the value. Let me do that. Divide through by 2 divide both sides by 2, meaning that you have 2 into 2x plus 2. If you open this bracket, you have x plus 2 plus x, meaning that you have a collection of like terms 2x greater than or equal to 24. Divide through by 2, and you have a 2x plus 2 greater than or equal to 12. Now, move that 2, we have 12 minus 2, and 2x is greater than or equal to 10, and your x is greater than or equal to 5. This is what the question wants us to do, to find the values of the range of values of x. But if x, the branch is equal to 5, 6, 7, and so on, then x plus 2 will be equal to what? 5 plus 2, 7. Yeah. 7. 5 plus 2, 7. 6 plus 2, 8. 7 plus 2, 9, and so on. So, that's the solution to that. Now, we want to look at graphs of inequalities in one variable. To plot this graph, we use solid and broken lines, such as this. Can be in any form anyway, depending on what the statement is saying. Broken line, represents the exclusion, the less than, greater than, and the solid line represents the inclusion, the less than or equal to, greater than or equal to. Now let's look at these examples. Sketch the graphs of the following inequalities. X greater than 1, x greater than 1. If I'm going to plot this, on the Cartesian plane, we have the x, the y and the x axis. This is the y and this is the x. Where the two lines meet, intersect, is called the origin, and it is labeled 0. Now, this statement says x greater than 1. Where is x equal to 1? This is x, x, 2, 3, and so on. If this is where you have x equal to 1, and this is exclusion, put the broken line this way. And the statement says greater, where you have numbers. So this line now, this broken line now, is dividing the sheet, the graph, into two, left hand side and the right hand side. Now we are going to shade off the required region. When we say the required region, this statement is saying x greater than 1. We have the excluding 1, we have 2, 3, 4, and so on. Therefore, I'm going to shade off this. This is where the region that is required. This is the region that is required, and this arrow is showing that it is continuous. This other side is not required. So that is how to shade the required region to sketch the graph of linear inequality in one variable. Example number 2. We have x less than or equal to -3. Let me go back to the Cartesian plane. It is still on x axis and it says -3. That shows I'm not going this way, I'm coming to this other side. -1, -2, -3, -4, and so on. So less than or equal to, let me first get where x is equal to -3. And because it is greater than or equal to, which is inclusion, I'm going to draw a solid line. Then let me satisfy this. Less than or equal to, where you have the numbers that are less than -3 is on this left. This line is cutting this plane into left hand side and right hand side. Therefore, this is where I have the area that satisfies less than -3. So that's for this as well. Then question number 3. I have y less than 4. If this is the plane and it says y, this is y, this is x, and this is the origin 4. I'm going up 1, 2, 3, 4, not drawn to scale, and it says 4. This is where I have 4. It is less than exclusion. So let me continue this. Put it up here. Therefore, and it says less than. Therefore, I'm talking about this area down below 4. Below 4. Area below 4. This is the required region. Down. It is continuous. And number 4, y greater than or equal to -2. Let me put my Cartesian plane this way. This is y, this is x, and it says -2. This is the origin, -1, -2, -3, -4, -4. Now it says y is greater than or equal to -2. It is a bold, a solid line. Oh, sorry. Where's my ruler? See this. Then let us shade the required region. Greater than or equal to, greater. The numbers that are greater. This particular line, this particular plane is divided into up and down, not sides now. From these two up, the numbers there are greater. -1 is greater than -2. So you have them this way. Should this region is required? This region is required. So that shows y greater than or equal to -2. So this is where we're going to end today's session. But before we go, let's take this assignment. This is the second assignment I am giving. So to be submitted, to be forwarded to this email address, fbcphcdgclass@gmail.com. And remember to indicate your name, your class subject, and the topic. So they are simple questions based on what we have learned today. Thank you. God bless you. See you next time.